This is problem number 21 of 2018 AMC 10A. Which of the following describes the set of values of A for which the curves x squared plus y squared equals a squared and y equals x squared minus a in the real xy plane intersect at exactly 3 points? The graph of quadratic function y equals x squared minus a is the parabola with its branches oriented upward. Its vertex has the coordinates 0 and minus a. Let's examine the case when a is negative. In this case, the vertex of the parabola lies at the highest point of the circle x squared plus y squared equals a squared. The coordinates of this highest point are 0 and absolute value of a. In this case, the circle and the parabola have only one point of intersection. Let's examine now the simple case when a equals 1. In this case, both the circle and the parabola cross the x-axis at the same 2 points with x-coordinates -1 and +1. In this case, the circle and the parabola have 3 points of intersection. The next simple case is when a is greater than 1. The parabola y equals x squared minus a, where a is positive, crosses x-axis at 2 points with x-coordinates minus square root of a and plus square root of a, whereas the circle crosses the x-axis at 2 points with x-coordinates minus a and plus a. If a is greater than 1, then plus square root of a is less than a, which means that the parabola crosses the x-axis inside the circle. Since the parabola's branches are oriented upward and they extend to infinity, they must cross the circle at 2 additional points, so that the total number of points of intersection is 3. The most interesting case is when a is positive and less than 1. In this case, square root of a is greater than a, so that the parabola crosses the x-axis at 2 points that lie outside the circle. The points of intersection of the parabola and the circle then may only be below x-axis. These 2 points of intersection then must satisfy the equation plus square root of a squared minus x squared equals absolute value of x squared minus a. After squaring both sides of this equation and simplifying it, we come to the conclusion that the 2 additional points of intersection of the parabola and the circle must have x-coordinates plus or minus square root of 2a minus 1. These 2 points exist only if a is greater than 1/2. The answer is E.